A stem plot displays the relative density and slope of the data. A stem plot contains two columns separated by a vertical line, and the left column contains the stem, while the right column contains the leaves. So you have an example. Consider a stem plot which indicates the number of laps a teenager can swim. So if you have this, you have 0, 2, 5, 7. I'm just giving you an example here. This is an example of a stem plot. You can see you have a leftmost stem, so you can say that the number of laps are 2, 5, 7. Then you can have 10, 12, 12, 14, 16, 16, 18, 19. Then for the third row you can have 20, 21, 29. Then you can have 32, 34, 35, 37, 37, 38, 39, 39. You can have 42, 44 and 50. Now coming to a histogram, distribution is uniform if its histogram is a straight line. So you draw the histogram. If the histogram is a straight line, the distribution is uniform. And outliers, we have come across this term outliers in an earlier video. Outliers are values falling outside the overall pattern. Okay, now we will have, if you see modes show major peaks in the data. And gaps show holes where no value falls. So coming to certain basic graphs. So if I look at this graph here, this is a left skewed distribution. And for a left skewed distribution, this will be the cumulative curve. This is the cumulative frequency curve. Then you have, this is a bell-shaped curve. And for a bell-shaped curve, this is the graph for it, the cumulative frequency graph. So this is a rather easy curve to remember. And then this is a right skewed distribution. And for a right skewed distribution, this is the cumulative curve. Now we'll just discuss a few questions. Supposing data is collected on 100 stamps, two variables are the color and width. So the question is, are these categorical or quantitative variables? So color is a categorical variable. Why is it categorical? Because it's depending on the name. And width is a quantitative variable. It is a quantitative variable because it is measurable. Let's discuss a few true or false questions. So question A, stem plots are useful for both quantitative and categorical data sets. So this is false because stem plots are used only for quantitative. Only for quantitative, because you can literally measure it, not for categorical. Okay, let's come to the next true or false in stem plots. Stem plots are equally useful for small and large data sets. So this is also false because stem plots are not useful for large data sets. Let's come to the third true or false. Stem plots can show symmetry, gaps, clusters, and outliers. So this is true because it can show everything: symmetry, gap, clusters, and outliers. Okay, the next true or false. Stem plots may or may not show individual values. So this is false because stem plots show individual values that we have seen in the earlier example. Stem plots show individual values. Let's come to the last true or false here. Stems may be skipped if there is no data value for a particular stem. So this is false because stem plots are never skipped. Stems are never skipped. So that gives us a basic introduction of stem plots. So thank you.